All right, hello everybody. Hopefully you guys are having a nice day off. Teachers have a work day. Yeah, I know you don't really have a whole lot of sympathy for us, but that's okay. So we're in here. We're going to be doing a lot of review stuff this week because our test is going to be next week. So I want to take a look at our quiz from the other day. We had some really good ones, and we also had some ones that let me know that we need to do some more work. Most people were pretty good with where it's asking this. What is the solute? What is the solvent? And of course, we take a look up and we know it's table salt is being dissolved into the H2O. So the one that is being dissolved is the solute. The one that's doing the dissolving is the solvent. That was pretty good right there. Solubility of solids is blank. Now, remember how we talked about turning all the questions into a statement? Some of the answers, a lot of people, most people got this right, but the ones that were getting it wrong, I don't think you were reading it out as a sentence, because if you did, you'd probably be like, huh? What did I just say? Solubility of solids. So the ones that I hinted to, I said, take a look at our graph. And we know down here we have our temperature, 0 degrees to 100. Here we have the solubility from only 10 grams to 100 grams. Let's look at most of the items. We got this one weird one. When it's cold, it can absorb almost 20, and then it goes down. But look at everything else. Cold, and then up here, the amount that it can absorb. This one, 0 degrees, that's what it can do. Up here, that's all it can do. Okay? And all of them going up, going up, going up. Okay? So, if you wrote going up, that would work. Or the solubility of solids is increasing with increasing temperature. Read the graph. Make sure you can read it. Almost everybody got this right. To increase the concentration of solution, you must increase the ratio of solute to solvent. When a solution cannot dissolve any more solute, it is said to be saturated. So when I get up here and it can't absorb any more, it's saturated. At what temperature do NaCl and KCl have the same? So here's NaCl. I know this is a little hard to read right there, and there's KCl. Look where they cross, right there. So I'm really taking from like 30 to 35 degrees. If you wrote that answer, and because it is a little hard to read, that's the temperature. What substance is most soluble at 10? A lot of people miss this because you missed this one right up here, up in the corner. Okay? That, if I go up, the idea is at 10 degrees, I go up from 10 degrees, and let's just keep going up. Let's find out what's my highest one. Oh, there it is. What substance solubility is least affected by temperature? A lot of people picked this one, which is actually going down. It's not here the whole time. It starts here, so there's actually a big decrease from about 18, to 4. The one that doesn't change that much, it goes here from like 32 to about, that's right at 40, right underneath 40. This one it changes the least. So that substance is least affected by temperature. When a solution is formed, is it a physical change or a chemical change? It is a physical. Anytime when we talk about mixtures, our solutions, we're talking about a physical change. Remember, I told you guys about how we could take the salt, take the water, dissolve the salt into the water. I can dissolve this stuff. And then if I heat it up, let it evaporate or whatever, I'm going to be left with the salt. So it didn't change. If it was a chemical change, I'd be left with something else. Okay? So that's the way that works. And what was your other question that was on there? A solution is a very evenly distributed mixture of substances. I took some other answers or gave you half credit if you came close to it, but mixture is really what we're looking for there. And if you were given a mixture of sand, salt, and charcoal in a beaker, you need to separate the mixture into the 3 parts. I gave everyone credit for that because I wasn't here when I believe you should have gone over it. So if you didn't, that was you're using hot water, so you're going to use the temperature to affect all that. All right, I want to show you one other thing. All right, I'm switching up the graphs here because I want to make sure as we're going forward and getting ready for the test that everybody has this. So I want to put it in a way that you could slow it down if you need to go over the X, Y axis when we're doing graphs, okay? If you notice here, they're talking about when they put coordinates out that the X axis comes first and then the Y axis, okay? So X is 1. If I look over here, 1. This is the X axis. This is the Y axis. Okay? The independent variable is going to be down here. Independent, the thing that I can switch up. Okay? So like temperature, I could control how much, what the temperature is on my graph. So if I go back here, nope. Wrong one, Mr. Schmeelcke. There we go. All right, let's go down to the graph. Temperature. This is the independent. This is the thing that I'm controlling. I can control if my mixture is going to be at 10 degrees, 50, or 100. And then the dependent, the thing that's going to change then the impact according to my temperature. If you notice, I put the temperature up, and now it can absorb more. So that's the dependent variable. It's dependent on what I did with this variable. So with your graphs, this, okay, know your X and know your Y. All right. We will be going over more of this in class, but I wanted you to have it in a format that you can go ahead and you can slow down, rewind. So we should be doing study guides this week. We're going to do some station work with review. We're going to be finishing up all of our lab reports. Those are going to be due this week with their sentences. Okay. And then next week, we are going to be taking the test. It's going to be an e-cart test, so it's going to be on the computer. And I know somebody's going to ask me how many questions it is, but I don't have that in front of me. And really, if you know the answers, the questions don't really matter. And if you don't know the answers, it doesn't matter if there's 10 questions or 100. All right, I hope you guys are having a good break. We'll put this in Twitter and Google Classroom. I forgot one last thing for all the parents out there who are watching this. All right, kids, if you're watching, I want your parents to watch this too, okay? Parents, if you're watching, this is what I want you all to do. Send me an email. rfschmeelcke@fcps.edu. So go ahead, send me an email. Let me know that you were able to see this, because I want all of you guys to know what's going on. This is how you're going to find out, like, hey, that there's going to be a test coming up, that they've been working on labs, what's going on, so that you know what's going on in your student's life. They know that you know what's going on. Okay, so everybody, yes, this is a little bit of an assignment for the parents, and I'm going to be bugging the kids if I don't see one, is send me an email letting me know that you saw it. Okay? That's it. Everybody have a good one. Bye-bye.